Hello guys, and welcome back to part 3 in the series of tutorials on implementing k-nearest-neighbor in Python. In our first video we downloaded some data called iris.data, which is in the form of a CSV file. It had 150 instances in total, 4 attributes describing the class, and then 1 class name. So what we're going to be doing over the course of the series, of course, is we're going to try and, based on these attributes, place some of these class instances into the correct classes. So the other thing we did in video 2 was set up our environment by installing pandas and Numpy. So what we're going to do now, we're going to open this Python file, and all we're going to start off with is we're going to import the pandas library as PD, and we're going to import Numpy as NP. Then the first thing we want to do is we want to create this list of attributes, and these are the attributes we saw when we were downloading the data. They describe each column of our data, and so these you want to make sure they're in the correct order. They're not technically required, but they'll actually just help us see what we're looking at, what our data is. And I don't know if I just stated this a moment ago, they're going to be the column headings of our data frame that we're going to be creating. So just make sure they're in the correct order. And then the last bit is just, if you remember from the CSV file, the last column was just our class data. What we want to do next is we want to create this thing called a data frame, and we're going to do this by using the readCSV method given to us by pandas. And all we need to do here is we need to go into our data folder, and we're just going to grab our CSV file, which is our iris.data. Then what we need to do to we're going to say, look, our names, our column names are going to be attributes. Make sure you don't actually write it like this. And this is quite important actually, because if you don't do this, if you leave this blank, then the first line of our CSV file is going to be the column headings, which means we're actually going to lose our first row of data. So just make sure you have something. Alternatively, if you don't want to give it a name, you can just say header equals none. So you're telling it doesn't actually have a heading in the data set, and it will automatically create you one with some numbers. And we're just going to print this data set now, this data frame, sorry, which is df.head. And this is just going to get df.head basically gives us the first 5 lines of our data. So you can see now we've got our column headings in the correct places, and we've got the first 5 lines of data. We can see it starts at 0, which is all nice. So we've successfully created this data frame that we wanted, and the goal of this video is to create 2 Numpy arrays. We want our data Numpy array, which is going to be the first 4 attributes, and then based on those attributes we're going to try and match it with our class. So we're basically now saying what columns of data do we want to be put into these arrays, and for our classes it's just going to be this column. So what we're doing with this line of code here is we're saying we're going to make a Numpy array which is going to consist of 150 instances, and it's just going to be our class column. And then alternatively, using the same logic, we want to, in the data array, our X array, capital X, we want to grab these 4 bits of data for every instance of data. And we do that by actually using this iloc function given to us by pandas. And in it we're going to say which rows do we want, and we're going to use colon, which tells us we actually want all of the rows, all of them. This is the equivalent, of course, of explicitly doing something like this all the way to 149. So we want all of those rows, but we can just grab that with colon. And then, like I just mentioned a moment ago, we want these 4 rows. So we're going to use some splicing. We say we want rows 0 and up to including 4, but we don't want column 5. Sorry, I meant columns. We want columns 0 to 4. So that's it. That's what we want. So we've actually created our two NumPy arrays, one with our tags, our class tags, and one with our attribute data. So let's print this and just make sure everyone can read it. Just going to make it a tad bit bigger. So our X array looks like this. Our first element is just a first row with these 4 columns, 5.1, 3.5, 1.4 and 0.2. Then our last row of data is going to be the 150th element, and likewise they match up. So iris setosa matches up with this data set in the same way, right? So element, if we go back to our Python script, actually, like this. What did I do wrong? I spelled Emacs wrong. So what we're saying is that actually the tag, so the tag of y0 is equivalent to the data we have at x0. So that's what we're saying. And this is going to allow us to train our k-nearest neighbor algorithm. So yes. So again, if all the videos haven't been subscribed yet, haven't been released yet, I suggest you subscribe if you want to keep up with them. And I shall see you in the next video, and thank you for watching.